Let's do an example using trigonometric ratios to find missing side lengths and missing angles in a triangle. When we do this, we call this solving a right triangle, where we find all the missing sides and all the missing angles. To do this, you need to have two side lengths or one side length in the measure of one acute angle. So let's do an example. So here it says to solve the right triangle, round side measures to the nearest tenth and angle measures to the nearest degree. As we can see, we're missing this side and we're missing these two angles. So remember, we're going to be using our trig ratios to solve for this. You can write them out. So the first one, actually, I'm going to write sine is my first one, cosine, and tangent. So we have to remember when we use the inverses of these and what each of these ratios stand for. So remember, sine is the opposite over the hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The first thing that I would try to find is all of the angles. So remember to find the angles, we need to have, we're going to put in the ratio of the sides. So this is the inverse, right? We're going to first use the inverse of these ratios to find the missing angles. So the first angle I want to find is x. If that's the angle I want to find, I draw a little person, a stick person, and then I label which sides are going to be my hypotenuse, which one is going to be my opposite, and which one's going to be my adjacent, so that it helps me figure out which ratio is best to use to solve that problem. So first I'm going to find angle x. If I'm standing on angle x, the opposite side from where I'm standing is going to be this one, so that would be my O. Adjacent means the side next to you, so the side next to you, that is not the hypotenuse. Remember, the hypotenuse is always going to be the one across from the 90-degree angle, so that's your H. Your H never changes. It's always right across from the 90-degree angle, and the side that is left is going to be your adjacent, the one that's next to the stick person. That is not the hypotenuse. So now that I've labeled all the sides, I want to find the measure of an angle, I have to have two numbers, two side lengths. So as you can see, there's no numbers here, no numbers on the H. So I want to cross out any ratio that has an H in it. It's not going to help me to find the measure of the angle. So I'm going to go ahead and cross out, eliminate sine and cosine because they both have an H. And now I know which one I'm going to use, which is the tangent. So now I'm going to say, okay, I'm going to use the tangent, and I'm going to use the tangent inverse because I'm looking for the angle. I'm going to input the ratio, and I'm going to get the degree angle. So remember, the tangent is the opposite over the adjacent, so the opposite would be 9, the adjacent would be 5. And all we have to do here is put into the calculator. And I'm going to check and make sure it's in degrees, and it is. Clicking on the little tool at the far top right-hand corner. And then I click on functions, and I'm using tangent inverse. We're going to put 9 over 5, and my angle is 60.9. They want the angle measures to the nearest degree, so 60.9 would give me, if I round it up, I'm going to get 61 degrees. So that's my angle x. Let's find the next angle. So now my perspective is going to change. My little stick person changes. So now I'm going to look for angle y. And so my little stick person, I'm going to change that perspective, and I'm drawing him on angle y. Remember, your hypotenuse never changes. It's going to stay there. But now your opposite and your adjacent sides switch. So now your opposite is the 5 and the adjacent is the 9, because now that's the closest to the stick person. So here, then we have to decide which one now are we going to eliminate. Once again, we still don't have a number on our h, so we're going to eliminate the ratios that have an h in it, and so we're still going to use the tangent. So we're going to use the tangent inverse because we're looking for the angle. And remember, it's opposite over adjacent, but now instead of 9 over 5, it's going to be 5 over 9. And so now we put that in a calculator again, and that's the nearest whole number, so that'd be 29 degrees. 29 degrees. You could also make sure that all the angles add up to 180 to be sure. And in this case, if you add these two, there would be 90 plus the 90-degree angle here. So far, so good. All right. Lastly, we need to find, remember, we're trying to solve the right triangle. So we need to find all the missing angles and all of the missing side lengths. So far, I found this angle to be 29, this angle to be 61. But I'm missing the hypotenuse, so I got to find that. So now we're going to look for the side length, side h, or side hypotenuse. To do that, there's several ways to do this. You can use the Pythagorean theorem, but since we're focusing on, and remember the Pythagorean theorem is a squared plus b squared equals c squared. Your hypotenuse would be your c squared in this example. But since we're trying to focus on the trigonometric ratios, we're going to use those instead. We're going to use that method instead. So we are going to choose which perspective we want to stand on. It doesn't matter in this case. So I'm just going to leave the stick person where it is on an angle y. And now the way that we pick the correct ratio we're going to use, we have to pick the one this time with the h because we want to find h. So we're going to put an x here, right? We're trying to solve for, actually let me use a black color so you can kind of see here. So that's your x, you want to find it. So I'm going to go ahead and eliminate tangent because there is no h in tangent. And now you're left with two options because we have a number on O and A. So we can pick which one we want to use. I'm going to go ahead and use the sine. And this time I don't need to use the inverse because we're looking for a sine. So this time we're going to go ahead and put the measure of the angle and get the measure of the sides here. So the measure of the angle for angle y is 29. Remember, the answer is going to be the ratio. So previously we inputted the ratio and out came the angle. Now we're putting the angle and we should come up with the ratio. Now what's the ratio for sine? Where the ratio for sine is opposite over hypotenuse, right? I know my opposite. My opposite is going to be 5, right? The number for O is 5. I don't know my H, so I'm going to go ahead and replace it with an X. If the X is at the bottom, you just want to switch the X with the sine 29 degrees. And so this becomes X is equal to 5 over the sine of 29 degrees. And so what you're going to put in the calculator is going to be this, and that'll be your hypotenuse. And now it's 10.3, and you can see the picture is kind of like at, basically there at 10.3-ish, right? It's not exactly 10.3, that's why it's kind of hard to say, okay, well, it's just exactly 10.3. It's 10.31. So that's why you can try to estimate it looking at your picture, but it's better if you try to get your x by itself. And so your answer will be 10.3. They want the side measures to the nearest tenth, so your hypotenuse is going to be 10.3 units. And I just want to point out, getting your x alone when you're dealing with trigonometry is pretty simple. If you have like the scenario 1, so I'll write it in scenarios. Scenario number 1. If you have like the ratio and an angle, let's say 30 degrees, and you have the ratio is 4 and x is at the bottom. If x is here at the bottom, all you have to do is bring it up and then bring your ratio down to where your x was. So for example, it becomes x is equal to 4 divided by the tangent of 30 degrees. And that's what we did. That's your first scenario. Your second scenario that you'll see, this one you'll have your ratio, let's say the same one's tangent of 30, but instead now your x is at the top and you have the number at the bottom. If this is the case, all you need to do is bring this, it's always what's at the denominator, bring this over here, 4 times the tangent of 30 degrees, and you'll just multiply them in Desmos and get your x. And that would be our second scenario. So in either case, it's pretty simple. Just look at your denominator and bring it up. Either you're going to bring it up and then also move the ratio down to the denominator, like switch them, or you're going to bring the number up and multiply it to your ratio. So you're either dividing by your ratio or you're multiplying to your ratio. That'll be easier to then put this into the calculator and get your whatever it is that you're missing, and or putting this into the calculator and get whatever it is that you're looking for. Because like we just showed you, if you put it in just straight up without anything, then you're gonna have to be estimating the response, and maybe you'll have some not so accurate responses. All right, really have some fun with this. This is really, really fun math. It's basically kind of an introduction to calculus. So if you've ever wondered what calculus was or pre-calculus, this is kind of the intro to that. So if you enjoy it, you'll be looking forward to that subject. So have some fun.